So hello, everyone, and thank you for joining us for our talk on best practices for SaaS performance monitoring. I'm Scott Sumner, the CMO at Kadiska, and I'm here with Boris Rogier, who's a co-founder and our Chief Operating Officer. So let's just jump right in.
When we think about observability and probably IT performance monitoring, most solutions have been built on the traditional model where basically users were located on company sites. They accessed data centers through private network, and in the data center, basically we hosted applications and we knew perfectly where they were hosted, and that was already not so easy. But basically, with cloudification, a certain number of new ways to access applications and host applications have become very frequent. It goes from the server side and the hosting side, basically, of hosting applications in the clouds using PaaS and IaaS, and also using SaaS applications provided out of the box and hosted by SaaS providers, by the software vendors themselves. With that, it has incorporated a new change also, which is basically accessing applications through public networks and through internet in general. And on the user end, we've seen two new very important additions, which is on one end SD-WAN, which allows basically to access the private regions in the public clouds and SaaS applications, and also data centers, but using public connectivity as an underlay. And the final part is really all the development around work from home and remote working, and the security solutions around remote working, like secured web gateways and CASBs, etc. So basically, that has changed the whole landscape as to how user basically access an application and where that application might be sitting. And it has also completely changed the way we can look at observability and the way we can monitor performance. So basically, when you think about it, when you look at the traditional ways to look at IT performance, for example, APM, you see major challenges. So basically, APM doesn't really apply if you don't have control on the system that holds the application, on the cloud that holds the application, and that's the case for SaaS. If you think of the traditional way of looking at performance from the networks angle, so NPM, well, they face also major challenges. So basically, there's no way you can easily capture SaaS and PaaS traffic. There's no way you can look into application transactions due to the encryption. And basically, that makes those solutions not really applicable to that new landscape. And finally, RUM. Well, RUM applies if you've got control of the application, and equally, it's not the case when you talk about SaaS applications. It's not the case when you talk about a lot of PaaS applications as well. So that's the problem that basically Kadiska looks at offering an answer to, and SaaS is a big component of it. So today we'll focus on SaaS.
That's great, Boris. I mean, it's actually quite amazing, right, to see how the transformation of SaaS has impacted businesses, and embraced it. And in fact, Kadiska itself, we're a SaaS application for monitoring SaaS applications. So we've come to the point where it's really the de facto norm. 80% of or more of business applications are SaaS. Ones that we may not, have thought of that way, like that started like SAP, have now completely migrated into the cloud in their newest versions, and it's become critical to the business because these are part of core activities. And it's often easy for us to forget how many things we use each day that are actually SaaS applications. All the Office suites, if you're using Google or 365 running in the background, collaboration like we're doing right now, all the manufacturing, logistics, but also the IT systems themselves are becoming SaaS oriented. So really integrating and connecting into all the different private and hybrid applications that we already have in our infrastructure, and to the point where things are all really working in a composed environment, very mixed, and the boundaries between SaaS and in-house and self-hosted and the platform as a service, traditional application hosting environments have really faded away, so that the interaction is much more important than anything else in terms of performance.
That's right. I mean, nothing is simple when you consider SaaS, and the fact that it actually has legs into the traditional IT as well as in the rest of the cloud solutions basically makes SaaS and SaaS performance management a complex topic. And it's also, SaaS performance is mostly something we regard from the angle of issues, incidents, and basically complaints from users. I mean, 42% of those users actually report poor performance on SaaS. It is a massive factor. And when you look at the number of companies that consider that basically their visibility on how people access the application through the network has evolved, I mean, more than half of the IT teams actually consider it has decreased. And basically, when you look at SaaS, it's very important to think about all the potential things that can impact SaaS. I mean, the sort of misconception around SaaS, which is basically not that common anymore because people get mature, is that SaaS is something that you access through the internet and you get to a set of servers and it's simple and basically it's delivered, it's working. Well, not really. SaaS is actually running on a large number of infrastructure components for its access and to deliver a certain level of performance. And it can go wrong at a certain number of points. So for example, when you connect your SaaS, you are redirected based on what the SaaS provider assumes is your location and what he assumes the local, the closest node is, and that can go wrong. So, for example, if you connect to a CASB, like a Zscaler, for example, you are located in one place. Maybe you are going to end up being redirected into another place. If you consider another element, I mean, the Wi-Fi of every remote worker is going to behave in a certain way. Every user is going to use a certain ISP, which has a certain internet path, which is dynamic and is going to change through time, driving different network capabilities and different sort of performance you're going to get from the network. And then if you place something in the middle, like Cloud Proxy or a CASB, you are going to have a first set of redirection, which is going to take you to one place, and then there will be another set of connectivity from that CASB platform to the SaaS, which will drive another influence on the end-to-end connectivity for the user. And finally, when you look at the app component, we usually think of application as something monolithic and something quite simple. Well, SaaS is exactly the opposite. It's very complex. So you've got a lot of host names that belong to different, that are hosted on different cloud platforms, that can be hosted on CDNs, that can be hosted on third parties. So that itself can go wrong and is very complex by definition. And finally, once you've got all the data on your browser still has to render it, and that can also go wrong. So there are a multiplicity of things that can go wrong when you're using a SaaS platform, which go far beyond what could go wrong when you use a traditional application hosted in a data center. So, okay, so we'll look at the same diagram basically and try to understand exactly what is a challenge from an observability point of view when we talk about SaaS performance. So the first thing which comes as a challenge, I mean, obviously, is that you've got no infrastructure control. So a lot of performance management stuff we have is based on the fact that we can monitor things at the network level, at the operating system level. And in the case of SaaS, obviously, I mean, we can't place any agent, and there's no way you can capture traffic on the server end, or at least on the SaaS platform. So that makes basically that option absolutely impossible, which takes away a lot of visibility that you would have normally used. The second one is encryption, and I would say strong encryption. For example, the implementation of TLS 1.3 or DFIRMAN before that make it absolutely impossible to decrypt traffic unless you change the architecture and you break the traffic flow between users and servers. So anything you could retrieve from analyzing network traffic basically becomes pretty dark and obscure and doesn't provide you with any insight on the user experience or on the application performance. Okay, and a third challenge is how distributed your users are. I mean, along with SaaS, we've seen that the traffic flows and the users are far more distributed than they used to be. People are in branch offices, they use local internet breakout to reach SaaS applications. They can be VPN users, they can be work from home users that use third party access to access the SaaS application. And that makes the getting visibility on the SaaS traffic a lot more complex because there are too many places to collect such traffic. So it's actually harder. And finally, on the application side, it's also far more distributed than it used to be. SaaS rely on multiple cloud providers. They normally use regional hosting strategies based on the best infrastructure they can use on a per regional basis. But they also use a lot of third party to host their images, to provide APIs, to provide authentication services, to provide all sorts of things. So basically, when you use a SaaS application, normally you're not going to connect to a handful of host names. You're going to connect to 20, 30 host names per SaaS application you're going to use. And that makes the whole picture a lot more complex than it used to be. And two additional facts. I mean, for each host name, basically, you're going to be redirected based on your location or what the SaaS provider sees your location to be, and basically they try to connect you to the closest node, but that doesn't happen as smartly as it should all the time. So that's also a source of errors. And finally, when you look at the evolution of SaaS applications, I mean, there's one major factor in the way they are built today. They've moved away from the traditional web applications where basically any interaction your users have take you to another page, and basically performance is measured by page loads. Page loads mean little things when your application basically mostly consists in downloading a JavaScript bundle, and that JavaScript bundle is going to make a different API calls to basically retrieve the data that you need to see. And basically your use is going to simply be a set of API calls, one after the other, rendered in the browser, but there will be no additional page load. I mean, you can take as an example BrightTalk. I mean, you're connected to your platform. You loaded something in the beginning of this webcast, and you haven't moved from one page to another. And basically, the initial page load is relatively irrelevant to what your experience is going to be when you connect to that webcast and how you view it. So that's a perfect example for an SPA. I mean, another good example would be Gmail, for example, which is familiar to a lot of you. Okay, so all of that makes basically performance visibility more complex, and basically explains why traditional performance monitoring solutions basically do not offer a proper solution. As I explained already, NPM solution, I mean, faces two major challenges. I mean, one is encryption, and basically the fact that you can see traffic to a certain degree. You can maybe allocate that traffic or recognize that traffic as belonging to one application or another, but you can't extract from that any experience metrics or application performance metrics. And there's a second challenge, which is it's almost undoable or very hard to do to implement traffic capture. So knowing exactly where you can capture traffic, you can't do it centrally from the SaaS platform. You can't really do it from the user end because it's too distributed. If you look at doing it in the middle, if you start using modern network solutions like SD-WAN and so on, your traffic matrix is going to be so complex that you won't be able to implement any form of traffic capture. Okay. Plus, there are some new protocols. I mean, sometimes people aren't that clear about it, but the way protocols basically process and help carry basically application requests require new decodes basically from the NPM solutions. And those NPM solutions are not so good at actually showing the content of HTTP2 and HTTP3 on top of the encryption obstacle. Okay. When we think of synthetic testing, well, synthetic testing is something that web monitoring has used a lot in the past. It basically consists in basically replicating what a user would do from a given machine and measuring the time it takes and actually getting some metrics out of that. It's great, but it works when you've got a usual scenario, a golden pass, basically, that is meaningful for you. That's great for an e-commerce site. I mean, basically, you had a product in your basket. At some point, you check out, and that's the scenario that really matters. When it comes to SaaS, it's far more complex, and there are basically plenty of scenarios you could think of, and it's hard to represent something which is representative of what users are going to do. And finally, synthetic testing is not great for single page applications because it's mostly focused on page loads. And as we mentioned before, that is not really meaningful for what you want to measure. And if you want to measure the experience, definitely not the right way forward. And finally, agent-based RUM. I mean, it is great, but you've got a certain number of obstacles. You could place something on the agent, an agent basically on the end user system, but that requires that you've got control of that. That requires that an agent is not an issue from maintenance of the operating system. And finally, that this is doable and that works on all platforms, including the ones that really do not really belong to your company, but are BYOD devices or Chromebooks, for example, which are not always addressable through agents. Okay, so that gives basically a picture where you've got a lot of challenges. The traditional solutions do not really address the problems, and basically you still have to understand exactly what are the drivers of the SaaS performance of your users. So when we look at drivers from the SaaS performance, so what would you need to monitor to understand what SaaS experience is? Here is a first indication of the main phenomena or pieces of infrastructure that you need to monitor. So from the users on top to all the set of public networks, so that would be like the internet, which is a massive group of public networks managed by different operators. In that bubble, you will find also cloud access platforms like CASBs and SASE solutions, and your SD-WAN will run as an overlay over that. And finally, you've got the SaaS platform, which, as we mentioned already multiple times, is distributed across multiple cloud providers and CDN providers. Okay, so the first thing you probably want to monitor is the latency between your users and all the hosts involved in the delivery of your SaaS platforms. So not one, but 20 plus hosts. And you may have some hosts to which a user has a short latency, and some others where the latency is actually far longer than for the other ones. Some processing delay is going to be added by proxy clouds in the middle. So if you've got, for example, solutions like a CASB, or if you've got a cloud proxy, or if you've got a VPN and then you backhaul to the internet to reach the SaaS platform, all of that is basically adding processing time, which will have an experience impact for your users. And finally, there is the network latency from that place to the different parts of your SaaS. So if we think not remote working, but really working from a corporate site, it might be an SD-WAN, it might be backhauled into some place, it might be a local internet breakout. But basically, you've got to understand how that connectivity is going to affect the user experience. And finally, there is more of an application side to what drives the experience. And basically, there are three main components to that. There is how fast the different servers basically involved into the SaaS application are going to respond. There is how long it takes to transfer the data based on how big the data is, how it's compressed or cached correctly or not. And finally, there is what is the time needed for the browser to render it and show it, and in which order we actually try to render the different parts or items in the application, which will have an impact on the user experience. So basically, if you want to start monitoring SaaS performance, you need to keep an eye on those six drivers to get a complete view of what drives the experience. Okay. So when we start looking at how to address SaaS performance, then you've got a sort of a stepped approach to implementing SaaS performance monitoring. I mean, obviously, the first thing you want to do is get monitoring in place. So it's having a view of what is the user experience and what is the user experience in the different work context in which people use their SaaS applications. So not only from your core sites, if 50% of your staff is actually working remote from their home offices or on travel or working from branches with local internet breakouts, basically monitoring only from your headquarters is not going to give you a good picture of the experience of your users accessing SaaS applications. So it has to be holistic. It has to address all the situation. And probably the second step is you want to identify in real time any degradation that would come up. And you probably want to understand right away what is the scope of that degradation. So basically, which users are having that degradation, or for which applications, where they are located, what is the way they access the SaaS applications? Is it through local internet breakout? Is it centralized? And for which transaction, which host names, and eventually which third party to the SaaS platform. Finally, you want to isolate exactly what is the infrastructure layer which is responsible for the slowdown, so that you can basically route that ticket or that incident to the right people. So it might be a browser issue, in which case that's more going to be either your endpoint or your application team, your SaaS platform, which is going to be responsible for that. That might be a DNS issue, that might be a network issue, that might be a CASB issue, which could be a redirection or a processing issue, and in which case it would be your CASB provider. That might be the server processing, in which case that should be escalated to the SaaS provider itself. Okay, so once you know that, you probably want to get to the root cause and understand exactly when the application, when the issue comes up, what is the real cause of the issue, so that you can provide the information to the SaaS provider, to the CASB provider, to the connectivity provider to fix the problem, or to one of your teams. And finally, once they start basically putting some resolution in place, you probably want to monitor that it actually fixes the problem from a quality of experience point of view, and actually be able to say, okay, the issue is fixed. It's no longer impacting the productivity of my users. So that's the full cycle you should cover.
Just to let you know, Boris, I've got quite a few good questions coming in, but I think when I look at them, questions about, how do we know which hosts are really affecting SaaS performance, and how do you measure things like transactional information to determine the user experience? Well, I think it's best to cover that with live data. So I think that's where, if you just give us a quick intro of how Kadiska works, then we can take the audience here into seeing some of these questions with live data.
Sure. I mean, those questions will be covered. And before we jump into the live demo, what I'd like to do is just use 1 or 2 slides to set the scene and basically explain how it works. So that, because, I mean, if I show the demo and people don't get exactly how we gather the data, how we collect the analytics and so on, they will not get a full picture. So let's start by this. I mean, the working principles are simple. We mix 2 sorts of analytics. One set of analytics is called Watcher, and that's basically real user monitoring data. So we actually get a view of the response times and errors for 100% of the transactions that are performed by users, and that can be deployed in 2 ways. That can be deployed from the application side for an internal application, so not the case for SaaS. And for the SaaS application, it's going to be deployed inside the browser of your users. So normally what you would do is deploy a plugin through a GPO deployment on all of your users. And we are going to get data which is going to be processed by the browser anyway. So we don't have any workload basically for the station. We are going to simply use the data that correspond to what you would use with Chrome DevTools or Firebug, and basically get a sort of a microscopic view of every interaction between the browser and the applications that you want to monitor, and especially the SaaS application. So that's User Watcher. And basically that's going to give us a picture of who's doing what with the SaaS application, where they're located, what is the connectivity that they have, what transactions are fast, what transactions are slow, and also what is the infrastructure layer contribution basically to the user experience, so that we can understand where the problems come from. If they come from a network issue, if they come from a CASB issue, if they come from a SaaS issue. And from there, we are going to cross that data with another set of analytics, which we call net tracer, which is basically active testing to automatically run extremely detailed diagnostics at the infrastructure layer, so at the DNS level, at the network connectivity level, at the network path level, so that we understand where we are redirected with what network connectivity as a result. And obviously, all of that will be placed in a super scalable analytics platform. Well, basically, we'll offer an intuitive path to root cause, where we'll provide automated baselining and a possibility to analyze the scope of degradations instantly. Okay, all of that gets deployed. I mean, the initial deployment is usually done in under 30 minutes. It requires nearly no maintenance, and basically that's what you're going to see now. Okay, so here we look at a small set of data, but that's the principle of what we do. So that's the data, the experience data, which is generated by user watcher in that case. So we see basically a list of applications that we want to monitor. Some are internal applications like Kadiska platform. Some are genuine SaaS like Google Meet, Mail, Calendar, Docs, Asana, HubSpot, for example, or CRM. And we see the number of users we get for each, the usage time on average spent by a user on that application. And first performance indicator, we see the average connectivity, so the average network latency from a user, wherever he's located, to that platform. And we can already see major differences. So for example, when you look at Google Drive, you see that the connectivity is usually extremely short. And when you see Asana, which is our task management platform, well, you see that connectivity is not so good for us. And you see the impact on the user experience. So you see page load indicators, I mean, for those applications that are still relying on page loads, for example. And you see API calls, processing times, I mean, for the single page applications. And as you see, I mean, connectivity has a huge impact on latency, and you see it basically translated here into the yellow section that you see here for Asana. That's the impact of the network latency involved by this relatively poor connectivity. So underneath that, you see a map that shows you basically where your users are. You can select basically the metric that you want to show. So for example, you could take, okay, where loading is good or bad. And you see that, for example, loading is not so good in Belgium in general, in our case. And you could basically see all users, or only remote users, or only on-site users. And then you can get a first view of where people are, how they are connected. So basically which ISP they use, and what connectivity and what experience they get, so that you can understand, for example, that people using free mobile, for example, get a good connectivity, a pretty bad experience, all based on their country, all based on the platform they use or the browser they use. Okay, if you want to take that aspect, I mean, going to the questions around CASB and their impact, for example, you can click on user groups and basically relate experience to a certain location. So you see number of users, you see the time needed to load pages, the errors, and beneath that you see a first map that shows you basically remote users on one end, on-site users on the other end, and basically on-site users are all the people that use corporate connectivity. And as part of corporate connectivity, we've got people connected through SD-WAN sites. So for example, you see our BD team in Toulouse, our product management team in Belgium, but you also see people coming through Zscaler, for example, having a relatively good connectivity to Zscaler, but here you see the impact through the redirect metrics. So that would be the proxy processing impact of a platform like Zscaler on the overall experience. So the red part, you see that, I mean, almost half of the time that is representing, you know, the overall experience for the users is the proxy time, for example, for a platform like Zscaler. And underneath that, you can see a map view of that. So You can see people located in different locations. You can see through which gateway they go and what sort of latency they get to both internal and external SaaS applications. Okay, that way you can decide basically where people are and what sort of performance they get. And in the same way, you could focus, say, you get a report for a performance issue during that peak, you know right away what applications were used. You know right away that, for example, we track LinkedIn. LinkedIn had a server processing time which was tremendously bad at that time. So that's probably it. And you can also see, which remote users were using which ISP from which country, which regions, or which city, and got a bad performance. Okay.
You know what, Boris? I'm just wondering, from a perspective of SaaS and connecting to the network, I was just trying to send a message over to you in Slack because my network connection seems to have gone down but I think the connection's gone down to Slack. Is there some way you can trace, the path that I'm taking and show what impact that has?
Oh yeah, we could do that. But before that, I'd like to answer one of the previous questions, so I don't leave it behind. So the last question I want to answer is if we take an example like HubSpot. So I'm going to take HubSpot used by different people in our team. So I see the different locations from which people connected to HubSpot, and I see the average connectivity and the experience. And basically, the question that your people asked in the first place is, how do I know about transactions that are good or bad? And the first thing you probably want to know is what transactions are the most frequent and really have an impact on the overall experience, and what transactions go bad and why they go bad. So the experience is in that table. So this is the most frequent request you're going to make to a HubSpot. And as you see, it's mostly driven by the blue line, which is server processing. So when it goes bad, the answer probably sits on the HubSpot side. And as far as which host we should monitor, then when you look at a solution, a SaaS application like HubSpot, you probably need to pay a lot of attention to how many transactions are processed by each host name. So as you see, most people using Synthetic would test hub.hubspot.com. And they would probably measure something which represents 1,500 transactions for that time, when you've got hosts that handle more than 10 times that volume of requests and are far more important when it comes to the experience of those users. Okay, so now I'm getting to your Slack problem. So if I want to understand, for example, what's happening on Slack, I can move to the sort of net tracer part and start looking at where hub.slack.com, for example, is easily accessible or not. And probably the first thing that strikes my mind is that some regions in the US do not get such a good connectivity. So basically, in this case, the blue is the short latency, the purple is on average a higher latency, and the red indicator, the larger, the more packet loss you see between our vantage points and the platform. So I see some problem on the West Coast, for example, for Slack. So I'm going to filter on that and look at the stations that I've got on the West Coast monitoring Slack. And the part that I see, in the first place, is that some places get relatively good connectivity. You've got two vantage points in AWS and GCP, so not the most interesting ones. But for example, from Los Angeles, you get 43 milliseconds, some packet loss. But from San Jose, same state, you get 143 milliseconds. As you see, it looks fairly stable when you look at the 7-day view. So we can look at that data and try to understand what is the difference in the way people access Slack from those different places. So what you are going to discover is that the SaaS network is complex. So what you see here is basically all the network paths that can be taken by a user to reach Slack from those places. So I'm just going to take a shorter time frame to simplify it. So you see small differences basically in latency, and you see a vast difference between the San Jose people and the Los Angeles people. So basically, in that diagram, what you see is Los Angeles vantage point, the San Jose vantage point, and what you see also is that they may be redirected to different places. So you've got Slack resolved into that IP address, which is 18 something, which is provided, probably hosted by Amazon UK. That IP address in 34, which is hosted by Amazon in the US, and that other one, which is in 54, but which is also hosted by Amazon in the US. So you see where I'm coming already. I mean, if you want to...
No, wait, Boris, you just said that the person in San Jose where they invented Slack is being redirected to some sort of hosting location in the UK?
We are going to get the answer right away. So if I just pick San Jose, in that case, they have been redirected to the UK at some point. At this point, they were redirected somewhere else to Highland, but they are never redirected to the US. Yes, that's correct.
Wow, I guess there must be busy servers there in the US that they're sending people overseas to access their messages. Might explain why I'm having a hard time reaching you.
Yeah, that could absolutely be it. Okay, and you've got plenty of other explanations that you can find. So if you take another example, for example, and wonder why some people experience some packet loss, for example, you can pick that region, see, for example, that from Austria. We see some packet loss. If you want to understand exactly where that packet loss is coming, if it's coming from the SaaS side, or if it's coming from another end, or GCP Frankfurt, for example, if you want to monitor those two. So we are just going to keep GCP Frankfurt and Graz in Austria as example. So you see you've got a bit of packet loss in each. If you want to understand where packet loss is occurring, and if it's a SaaS provider side issue, or if it's a networking issue, well, you're going to see that you've got some short distance routes and longer distance. But if you want to see where loss is happening, it's happening on the Tata communication network here. Okay, so I exit GCP, go straight onto Tata, and I use the Tata network, and before that node, I get massive loss, for example. And that explains why I have a lot of loss on the way to Slack from GCP in Frankfurt. Okay,
so that's the kind of capabilities we have. IT help desk, right? What if somebody called me and said this loss is happening and you discovered this? Is there something they can do? Like, what's in their control in this point?
Well, that really depends on the user's context. If you use, for example, if that user is sitting on an SD1 branch, I mean, they've got two underlay, they might switch from one underlay to another. They might redirect, the traffic through the sort of data center and back all the traffic instead of breaking out locally. So that would be one way.
Mm-hmm.
If the loss is happening on the SaaS side, then there's definitely a ticket that you can raise for the SaaS provider. If loss is happening on your ISP providing the underlay for your SD1, then you can definitely open a ticket and get a resolution down by your operator.
Yeah, so one of the big advantages here is just being able to manage all these different vendors, I guess, that otherwise you wouldn't know who to call. Absolutely.
And if you take, the examples of large corporations that use our solution to enter the SaaS access, when you've got 200 SaaS applications, well, basically you might route through the transit provider A or B, the different applications to get to the peak performance, and basically you might actually change your BGP settings, or you might ask your provider to change their BGP settings to improve the route to critical SaaS applications for your company.
I guess there's another question here that I just saw coming in about, refers more to the user experience monitoring that you were showing before. there's people working at home, and their question was, how would my user experience be recorded? Do I need to install something on my machine? Is this practical when people are at home using Chromebooks? Like, how would an IT team actually instrument that?
Well, it's relatively simple. I mean, we provide a broader plugins or extensions through the Chrome Store, through the Edge Store, through the Firefox platform. And basically, there are two ways that can be installed. That can be installed manually from the Chrome Store, but that can be installed through a GPO deployment. So basically, in a few seconds, you install it on thousands of endpoints and their browsers. And it's not a deployment on the operating system. It's just deployment on the browser. So basically, whether you use a Chromebook, a Mac, or a Windows platform doesn't make a difference.
Okay, so that's a pretty lightweight way to reach those people that they come into the office one day and then they're back at home another.
Yeah,
so
absolutely.
Them, actually.
And the impact on their RAM and CPU usage is going to be close to zero.
Okay, so is there another easy way to do that, or is that really the only way to instrument?
Well, that's probably the best way to look at experience for SaaS platform, for sure. I mean, there's no other way, to understand.
Yeah, I guess we're past the point where you can just take a look at the traffic and inspect it now, right? So,
yeah,
that's good. So those were the key questions we had, Boris, and we have a few things to share with our audience just before we do wrap up. One of them is, if you look on the right sidebar of the BrightTalk single page application, you'll see we have this presentation available to download as a PDF, and also a link through to some more expertise on troubleshooting SaaS applications and methods for visibility. And I also wanted to share with the audience here that those of you who registered and attended are eligible to try the Kadiska platform for free, and also get a quick assessment from our experts on a key application, a key SaaS application that may be causing difficulty for your users. And those details of how to take advantage of that, I'll be sending those out after the session. So I'd like to thank you all for attending, and also, Boris, thanks for, as usual, your expertise in guiding us through this maze of SaaS application performance.
All right. Thank you all.